Good morning everyone, I'm Ashna Sawan and today we'll be discussing about regularization and we will be focusing on two types of regularization, L1 regularization and L2 regularization. So firstly, let's understand why do we need the regularization. So machine learning models can overfit the training data, that they can perform strongly on the training data but poorly on the unseen data. And here regularization helps to prevent the overfitting by penalizing the large model parameters, that is weights. It ensures that the model will generalizes well to a new data. For example, in linear regression, if the model fits noise in the data, regularization reduces the unnecessary weight magnitudes to simplify the model. Then what is this actual concept of regularization? So regularization is a technique which is used in machine learning to prevent the overfitting and performs poorly on the unseen data. By adding a penalty for complexity, regularization encourages the simpler, more generalizable models. That is, regularization adds a penalty term to the loss function to control the model complexity, and it prevents the overfitting. How it does? It adds the constraints to the model to reduce the risk of memorizing the noise in the training data. And also, it improves the generalization by encouraging the simpler models that perform better on new unseen data. So basically, there are two types of regularization in machine learning. One is ridge regression and second is lasso regression, that is L2. Ridge regression is called as L1 regularization and L2 regularization is called as lasso regression. Then, what is lasso regression? A regression model which uses the L1 regularization technique is called as lasso regression. It adds the absolute value of magnitude of the coefficient as a penalty term to the loss function. As we have discussed that in regularization we add the penalty term to the loss function. This penalty can shrink some coefficients to zero, which helps in selecting only the important features and ignoring the less important one. And to calculate this, the formula is as follow: 1 upon n summation, where I is initialized to 1, to n yi to yi hat square bracket plus lambda summation, where again I initialized to 1, to m, and omega I, where m is the number of features, n is the number of examples, yi is the actual target weight, and yi is the predicted target value. So here yi is the actual value and yi hat is the targeted value. Now let's understand what is ridge regression. Ridge regression model is a model that uses the L2 regularization technique, and that's why it is called as ridge regression model. It adds the square magnitude of the coefficient as a penalty term to the loss function. Here this is the difference. It adds the square magnitude. Then it handles the multicollinearity by shrinking the coefficients of correlated features instead of eliminating them. And again, as you can see the formula, cost is equals to 1 upon n summation, where I is equals to 1 to n yi minus yi hat square bracket plus lambda summation, again wi square. Here w represents the weights, represents the number of example or data points, m is the number of features, that is the predictor value variables, yi again is the actual target value, and yi hat is the predicted target value for the ith example. Here we are discussing about the specific ith example. Wi is the coefficient of the features, and lambda regularization parameter that controls the strength of the regularization. Here, in the working examine mechanism, we can see that the regularization term is added to the cost function during the training. During optimization, it forces the algorithm to keep the weight small. L1 can set some weights exactly to 0 for feature selection, and L2 shrinks weights but does not make them 0. As you can see in the graph, without regularization, there was a problem of overfitting, and by applying regularization, the overfitting problem was solved and it is a good fit. The model is of good fit. So basically, regularization strength as increases, the model becomes more simpler and it is easy to handle the model. Then what are the limitations of regularization? Choosing the right lambda value is difficult. It is too small. If it is too small, overfitting occurs. If it is too large, underfitting occurs. Then L1 may ignore useful correlated features by zeroing them. So this is also a challenging task. L2 does not perform automatic feature selection. It does not perform automatic explicit feature selection. Then computational cost slightly increases during the training. So these are the limitations of regularization. Then what are the takeaways from this regularization concept that we have learned today? Regularization improves the model generalization and it reduces the overfitting. As we have seen that it does it by adding the penalty term to the loss function. Then L1 lasso regression, it promotes the sparsity which is useful for feature selection. Then L2 ridge regression, it promotes the small smooth weights and because of it, it can give a stable solutions. So balancing the regularization parameter lambda is crucial for optimal performance. A combination of both elastic net is often used in practice for better control and performance. So this was all about regularization. Thank you.